This is Babitha, working as Assistant Professor in the Department of ECE in Institute of Aeronautical Engineering. So in this session, I'm going to discuss about the definitions and terminology on diode circuits. That is the first module. So before going to the definitions and terminologies which are present in the diode circuits, first of all, what are the contents which are present in the first module? We'll see now. So here in the first module, we are going to discuss about the PN junction diode as well as about transistor. We have two parts in the first module, PN junction diode as well as the transistor. So in the PN junction diode, we will see what is meant by PN junction diode, what is the construction and operation of the PN junction diode, and what are the current voltage characteristics of the diode. And after that, we will see the applications of the diode. In the applications of the diode, we are having the rectifiers, clippers as well as clampers here. So in the case of rectifiers, we are having half wave rectifier as well as full wave rectifiers, and clamping circuits and clipping circuits. So these all are the applications of the PN junction diode. Rectifiers, clippers as well as clampers. Okay. And while coming to the transistor, in this we are going to discuss about what is meant by transistor and why we are moving from the diode to the transistor, and what are the disadvantages of the diode and how we are overcoming that disadvantages in the case of transistor, and different input as well as output characteristics of the transistor in different configurations, that is CB, CE and CC configurations, and different biasing circuits required for the transistor in order to operate it as faithful amplification process, and what is the load line analysis, and different amplifiers in the common emitter, common base as well as common collector amplifiers, and the small signal equivalent circuits of these all three amplifier circuits. So this and all we're going to discuss in the first module. So the terms which are related to the diode circuits we are going to discuss now. So before going to the diode circuits, first of all we have to know what is meant by electronics. So electronics, we can define it is the study of how to control the flow of electrons here. So the flow of electrons which indicates the electronics here. So if it is deals with the circuits made up of components that control the flow of electricity are indicating with the electronics here. So we can also define this electronics is the field of science and engineering which deals with the flow of electrons through a vacuum tube or through a gases or through a semiconductor material here. So this is also one of the definition of the electronics here. So in the olden days, we are utilizing the vacuum tubes to design the electronic devices and later on gases. But nowadays we are utilizing the semiconductor materials in order to design any kind of electronic components or circuits. And one more definition here it is the branch of physics and technology connected with the design of circuits using transistors and microchips, and with the behavior and movement of electrons in a semiconductor, conductor or a vacuum or a gas. So this indicates the electronics. So among these three definitions, we can utilize any one for the electronics here, but in most of the cases we will utilize this particular definition. It is the branch of science and engineering which deals with the flow of electrons through a semiconductor or a gas or a vacuum tube here. And second one is what is mean by conductivity. Define conductivity. So conductivity is nothing but the ability of a material or metal to conduct electricity when a potential difference is applied to it. That is nothing but if you take one particular material or conductor, if you provide some voltage to that. Okay. So if you provide some voltage means it will give some corresponding current, so that we can say how much amount of current it is providing proportional to the applied input voltage indicates the conductivity of that particular metal or material here. So that particular current is depends upon the how much voltage we are applying for that particular conductor. Okay, that indicates the conductivity of particular metal or device. And second one is, the next one is define the voltage. So voltage, we can also call it as the potential difference. Okay, and we can also call it as electromotive force or electric pressure or electric tension. So in these ways we can able to call the voltage here. So what is mean by this voltage here? It is the electrical potential difference per unit charge between the 2 points in an electric field. It is nothing but if you take any particular circuit that composed of different elements. Suppose I am taking here it has the resistor and capacitor. So the difference or potential difference between the points indicates the voltage here. So this particular voltage we are calling it as the input voltage, and this particular voltage between these 2 points we are calling it as the output voltage or output potential difference, and this one is the input potential difference. So it indicates how much amount of voltage which is present in this particular circuit here. And this voltage generally we will indicate with the symbol V or E, capital V or capital E, and we'll measure in terms of volts or millivolts or microvolts. These are the units for the voltage. And in the case of electrostatic field, so the work required to move per unit of charge between 2 points is also known as the voltage. So mathematically, voltage we can express as work done by charge with respect to charge W by Q here. And next parameter is the current. Define current. So current indicates the flow of electrical charge. That is nothing but electrons. Again, the movement of electrons indicates the current here. So generally current will flow from negative to positive points here. So the unit of the current generally we will measure in amperes, and the symbol for current we will indicate with capital I, and the units are amperes. This also is in milliamperes or in microamperes or in nanoamperes also we can measure this current. And generally if we take 1 ampere amount of current is nothing but 1 coulomb of electric charge moving past a unique point in a second here. That is nothing but in a fraction of 1 particular second how much amount of ampere current is generating from the electrical charge indicates the current here. So generally this current is widely used in all the industrial applications as well as household applications. In anywhere we will utilize this current here. And the next parameter is define resistance. So generally resistance is nothing but the opposition to the flow of the current in the electrical circuit here. Okay, the opposition of the current indicates the resistance here. So generally the resistance we will indicate with the R, and the units for resistance is ohms. Okay, we can also call it as omega. And so this resistance will give the relationship between the voltage as well as current in the circuit. So according to Ohm's law we can write resistance is equal to voltage by current. So from this relation only we are telling that resistance is inversely proportional to the flow of current in that particular circuit. So this is also available in kilo ohms or mega ohms, etc. And next parameter is define inductance. So here inductance is the passive element, okay, and it is also called as electric inductor. So it is defined as a two-terminal passive electrical element that stores the energy in the form of magnetic field. Okay, the inductance will store the energy in the form of magnetic field whenever the electric current flows through it. So it is also called as coil, chokes, or reactor here. So these inductors are available in the range from 1 microhenry to 20 henries here. Okay, so these inductors are having made up of ferrite or iron inside the coil, which is used to increase the magnetic field as well as the inductance of the inductor here. So we will indicate with L here. So the units are henries. And the next parameter is define capacitance here. So in the case of inductor, it stores the energy in the form of magnetic field. Similarly, the capacitance is used to store the energy in the form of electric field here. So that is the basic difference between the inductance as well as the capacitance here. So these capacitors are also available in different sizes. So generally this capacitor we will indicate with two parallel plates, okay, with positive plate and negative plates, and these two plates acts like a conductors here, and this gap between two plates acts like an insulator. We can also call it as electric field or insulator between the two conducting plates are nothing but the capacitor here. Here these particular capacitors are made up of either ceramic or film or glass or other type of materials here. So the capacitance we will indicate with capital C. So the units for this capacitance is farads. And next one is define circuit. So what is mean by circuit here? If we take any closed loop, that one we can call it as the circuit here. So circuit came from the word, it has circuit. A circuit is a collection of real components, power sources and signal sources all connected, so current can flow in complete circuit. If all the elements are connected in particular one loop, that particular loop we can call it as the circuit here. And what is mean by electronic circuit? Define electronic circuit. See, electronic circuit is nothing but one closed loop. In that closed loop, different components are connected from one point to the another point. So in that in the 2 points, we may include different electrical components. We can include either resistors or capacitors or inductors, whether diodes or transistors or any components or elements we can able to include in that circuit. So that is nothing but the electronic circuit here. So the circuit consists of all the electronic components. We can call it as the electronic circuit here. And next one is define conductor. So conductor is nothing but one type of material here. So the conductivity of this conductor is very high here. So if we take any particular material, so materials are available in three types. One is conductor, and second one is semiconductor, and third one is insulator. Okay, conductor, semiconductor and insulator. So the conductivity of any particular material we can able to differentiate by using its energy band structure here. So in the case of conductor, if we see the energy band structure, here we are having the valence band and here we are having the conduction band. So in this case, both the bands are overlapped here. So there is no energy gap between the valence band as well as conduction band in the case of conductor. So that's why it is having very high conductivity here. Okay. So the examples for this conductor is copper, aluminum as well as silver. These all are the good conductors. So high conductivity is nothing but those can able to allow the high amount of current through it. And second one is define semiconductor. So the second category of material is semiconductor. So in the case of semiconductor, the conductivity is not more than the conductor and but not less than the insulator here. So the conductivity lies between the conductor as well as the insulator in the case of semiconductor. So here it is, the examples are silicon and germanium materials. So in this case, if we see the energy band structure of this semiconductor material, we are having the valence band as well as the conduction band. So there is a gap between the valence band as well as the conduction band. This is the energy gap. So almost 2 electron volts energy gap will present between the conduction band as well as valence band here. So because of that reason only the conductivity lies between the conductor as well as insulator in the case of semiconductor material. But in almost all the designing of electronic components, we will utilize either silicon or germanium semiconductor materials only because of a medium range of conductivity here. And next one is, what is an insulator here? So insulator is a material that offers very low level of conductivity here. Why it is providing very low level of conductivity here? It is means in the case of energy band structure of this one, this is valence band and this is conduction band. So the gap between this valence band and conduction band is 9 electron volts. It is very high. So in this case, there is less chance of electrons will move from this valence band to conduction band here because of this long gap between both the bands. Because of that reason, it is having very low level of conductivity. So the examples for this insulator is wood, glass. So because of this reason only we are utilizing the semiconductor materials only. Why? Because in the case of semiconductor materials, it is not providing very high conductivity and it is not providing zero conductivity. So for any circuit, if we are providing very high energy means it may cause damage to our circuit. Or else if we provide very low conductivity means it will not function here. So because of that reason only we need to maintain the medium range of conductivity. So to maintain that medium range of conductivity only, we are utilizing the semiconductor materials in the designing of electronic circuits. And next one is define intrinsic semiconductor. So the pure form of semiconductor material is called as intrinsic semiconductor. So the examples are silicon and germanium. Pure form of semiconductor materials are nothing but we are not at all adding any impurities to this semiconductor material. But the current conduction in this intrinsic semiconductor is very less compared to the extrinsic semiconductor. So next we will see what is meant by extrinsic semiconductor. Define extrinsic semiconductor. So the current conduction capability of semiconductor material were increased by adding some external impurities to that semiconductor material. So the process of adding impurities to the intrinsic semiconductor is nothing but the extrinsic semiconductor. So if we add that particular impurities means we can able to improve the number of majority charge carriers in the material so that the conductivity of the material will be increases. So that indicates the extrinsic semiconductor. So these extrinsic semiconductors are available in two types, that is N-type extrinsic semiconductor and P-type extrinsic semiconductor. In the case of N-type semiconductor materials, electrons are the majority carriers and holes are the minority carriers. And similarly, in the case of P-type of material, holes are the majority carriers and electrons are the minority carriers. So that's why it is called as N-type of material. Why? Because electrons are more. So this is P-type of material. Why? Because holes are more. Holes are having positive energy. Electrons are having negative energy. So that's why it is N-type of material. And this one is P type of material here. And next, define diode. So here, how we can make the diode means we have to take one piece of P type of semiconductor material and one more piece of N type of semiconductor material. So if we join these two materials so that it form like a PN junction diode. So the function of this PN junction diode is to control the flow of current in the circuit, and it is a unidirectional device here. Diode is a unidirectional device. Always the current direction is from anode to cathode, that is from P region to N region here. And next, what is static resistance? So static resistance of a diode at a particular operating point indicates the DC resistance of the diode. That is nothing but if we take the characteristics of the diode, that is voltage versus current characteristics of the diode. In the forward characteristics, almost we will get like this, that is depends upon the how much amount of input voltage we are providing here. So on this particular characteristics, I am taking one point. So on this particular point, how much amount of voltage is there and how much amount of current is there. So the ratio of this voltage and current will give the static resistance of the diode. It is nothing but at one particular point on the characteristics of the diode, how much amount of resistance is there, that indicates the dynamic resistance of the, static resistance of the diode. And next one is define dynamic resistance. So dynamic resistance of the diode we can determine again from the characteristics of the diode only. Again I am considering the VI characteristics of the diode, and here I am taking 2 points on the characteristics. I am taking 2 different points on the characteristics. So this is V1, V2, and similarly this is I1, I2. So this V1, V2 I am indicating with delta VD, and this I1, I2 I am indicating with delta ID. So the variation of the voltage with respect to the variation of the current here. So the dynamic resistance we can write it as del VD by del ID. That is nothing but it is determined by a straight line drawn between the two intersections of the maximum as well as minimum values of input voltage. So static resistance is at one particular point, but the dynamic resistance indicates the variation of the voltage as well as variation of the current in the diode. And next, define drift current. So drift current is the electric current or movement of charge carriers which is due to the applied electric field, often stated as the electromotive force over a given distance. That is nothing but if you take one particular circuit, for example for the diode only, I am considering the diode circuit. If we apply some voltage to this diode, so there is a movement of current in the diode. So that current we will indicate it as the drift current. So whenever we are applying the external voltage to the circuit, if the current is generating means that is the drift current. And next, define diffusion current. So diffusion current is occurring in the device without application of any voltage here. So here in this case we are applying some input voltage, but here in this case I am not applying any voltage. VI is equal to 0. Even though the input voltage is 0, because of the movement of charge carriers from P to N and N to P, some amount of current is generating in the device. That current we are calling it as the diffusion current here. So the diffusion current is a current in a semiconductor caused the diffusion of charge carriers. Diffusion of charge carriers is nothing but movement of charge carriers, that may be electrons or holes. So this is the current which is due to the transport of charges occurring because of non-uniform concentration of charge particles in a semiconductor material. So here P and N are the semiconductor materials. And next, define diffusion capacitance. So diffusion capacitance is nothing but the capacitance due to transport of charge carriers between two terminals of the device. Again, in the case of diode only, we are telling this. The diode, how much capacitance is existing due to the diffusion process, that indicates the diffusion capacitance, and that we are indicating with dq by dv, the variation of charge with respect to the variation of the applied voltage. And next one is define transition capacitance. So the amount of capacitance changed with increase in the voltage is called the transition capacitance here. That is nothing but diffusion capacitance is occurring whenever the input voltage is 0. So this is occurred whenever the input voltage is present in the circuit. So whenever the input voltage is present, how much amount of capacitance is generating in the circuit indicates the transition capacitance here. So the transition capacitance is also the amount of charge to the amount of voltage applied to it. And next, what is load line? So load line is the line drawing on the characteristic curve or graph of the current versus voltage in a non-linear device like a diode. That is nothing but the VA characteristics of the diode is voltage versus current, and this is the characteristic, and this is the load line. So how we can draw this load line means we have to find this particular voltage and this particular current, and if we join these 2 points, so wherever this line cutting on this curve indicates the Q point, and this particular line we are calling it as the load line here. And next, define storage time. So this storage time indicates the timing, one of the timing of the diode here. So here this is the time period for which the diode remains in the conduction state even in the reverse biased state is called the storage time. That is nothing but for the diode we are providing some particular voltage, but at some instant we are removing that voltage. So after removing that voltage, at that instant only it will not come out from that conduction state. It will stay some amount of time in that conduction state. So that conduction state or time we are calling it as the storage time of the diode here. Next, define transition time. So the transition time is nothing but the time elapsed in returning back to the state of non-conduction state. That is, steady state reverse bias is called the transition time. That is nothing but once the diode is in the off state. So whenever we are providing the voltage to the diode, again it will go to the on state. And if you remove the voltage, again it will move to the off state. So whenever it is switching from off to on and on to off, it will take some time. So that particular time duration we are calling it as the transition time of the diode. Next, define forward recovery time. So the time required for the diode to change from reverse bias to forward bias is called the forward recovery time. So whenever we are providing the voltage to the diode, it will change from reverse bias to forward bias. But while changing that, it will take some time. That time we are calling it as the forward recovery time of the diode. And next, define reverse recovery time. So the time required for the diode to change from forward bias to reverse bias is called the reverse recovery time. So if it is changing from reverse to forward means forward recovery time. If it is changing from forward to reverse means it is reverse recovery time. And next, define peak inverse voltage. So the peak inverse voltage or peak reverse voltage is the maximum value of the reverse voltage which occur at the peak of the input cycle when the diode is in reverse biased condition. When the diode is in reverse biased condition, how much amount of voltage is present in that condition indicates the peak inverse voltage of the diode. The maximum voltage, how much it is holding, that indicates the peak inverse voltage. Why it is called as inverse means when it is in the reverse bias condition, it is indicating. So that's why it is called as peak inverse voltage, the maximum voltage in the reverse biased condition of the diode. Next, what is a rectifier? So here rectifier is a circuit which converts the AC voltage of main supply into pulsating DC voltage using either one or more number of PN junction diodes. So it will convert AC to DC here. It will convert AC to DC one. That may be the voltage or current here. Next, define ripple factor. So ripple factor, it is the ratio of root mean square value, RMS value of the ripple voltage to the absolute value of the DC component of the output voltage. That is, RMS value to the average value indicates the ripple factor of the rectifier here. Next, define efficiency. So efficiency, generally it indicates the output to the input, the ratio of output to the input here. So in this case, it is the ratio of output power to the input power in the case of rectifier circuit. And next one is define ripple factor. So it is the ratio of RMS value of an alternating current component in the rectified output to the average value of the rectified output. That is nothing but after rectification we will get AC to DC form. But this is not pure DC form. It is the pulsating DC form. Pulsating DC means in this DC some amount of AC is also present. So in order to estimate how much amount of still AC content is present in this DC indicates the ripple factor. So it is almost always this value is less than 1. So we will indicate with gamma. This value must be less than 1. What is peak factor? So peak factor is defined as the ratio of maximum value to the RMS value of an alternating quantity. So the alternating quantities can be either voltage or current here. So the maximum value is the peak value or the crest value or the amplitude of the voltage or current. So it indicates here it as maximum value to the average value or RMS value. What is a form factor? So form factor is the ratio of RMS value to the average value of the waveform. So the waveform can be anything here, either voltage or current. So this parameter generally utilized in the rectifier circuit. So it is RMS value to the average means DC value. RMS value to DC value indicates the form factor. And next, to define cut-in voltage. So the cut-in voltage, we can also call it as knee voltage. It indicates the forward voltage at which the current through the junction starts increasing rapidly is called the cut-in voltage of the diode here. So for example, if we see the voltage versus current characteristics of the diode, so it is the curve like this. So this indicates the cut-in voltage, kV gamma here. So till this point, the increment or variation of the current is very less. It is slowly changing. But after this cut-in voltage, there is a rapid increase in the current. So that indicates the cut-in voltage, that particular voltage, wherever the increment of current is more, that point indicates the cut-in voltage. And next, define clipper. So this is the application of the diode. So clipper is a circuit. It will remove or clip some portion of the applied input signal. So it may clip either in the positive direction or in the negative direction or in the both the directions. Okay. So these clippers are also called as limiter circuits in order to remove or eliminate some portion of the signal above or below the specified clip value. So for example, if it is removing the positive portion of the applied input signal, means we will get the waveform like this. So this portion is clipped off. And if it is clipping in the negative half cycle, means in this. If it is clipping in both the half cycle, means we will get the waveform like this. So in these three ways we can utilize the clipper in order to remove some portion of the waveform. So why we are utilizing this means in order to remove the noise information in the waveform. Next, define clamper. So the basic function of the clamper is to shift the waveform above or below the DC level or reference level. So how it can shift means by adding some DC value to the AC waveform, we can able to shift here. Suppose I am having the waveform like this, some square wave, okay, and I am shifting upward means I'll get in this way, the same waveform I'll get like this. So this amount of DC level is added here. And if it is shifting down means I'll get the waveform as in this way. So this amount of DC level is shifted down here. So if we wanted to shift upward means we have to add DC value. If we wanted to shift downward means we have to subtract the DC value to the waveform. And next, what is transistor? So transistor is an active semiconductor device. It is capable of performing the amplification as well as switching and oscillation. So the name is a contraction of transfer of resistance from low to high here. Transistor means transfer of signal from low resistance region to high resistance region here. It will transfer the signal from low resistance region to high resistance region. So why we are calling it as a low resistance region to high resistance region means in the transistor, input junction is forward biased, output junction is reverse biased. So input junction is forward biased means the input resistance is low. Output junction is reverse biased means the output resistance is high. So the function of it one is to transfer the signal from low resistance to high resistance, from input side to output side. So because of that reason, we are calling it as the transfer of resistance from low to high. And next, what is biasing? So biasing is the process of setting a transistor's DC operating voltage or current conditions to the correct level so that any AC input signal can be amplified correctly by the transistor here. That is nothing but generally in order to operate any device, we need to provide proper biasing to that. Then only it can able to provide the proper amplification. So in order to set the proper DC operating point, we need to provide proper biasing to the amplifier circuit. And what is meant by amplification? So it is the process of producing a larger voltage or current or power using a small input signal. So the function of the amplifier is to amplify the applied input signal. That may be the voltage or current or power signal here. So what are the junctions present in bipolar junction transistor? So two junctions are present here, that is the emitter based junction or emitter junction and collector based junction or collector junction, which are present in the bipolar junction transistor. Next, what are the operating regions of the BJT? So generally BJT operating three regions, that is cutoff region, okay, that is cutoff region, saturation region and active region. So in the case of cutoff region, both the emitter based junction as well as collector based junction are reverse biased. And in the case of saturation region, both the emitter based junction as well as collector based junction are forward biased. So in the case of active region, emitter based junction is forward biased and collector based junction is reverse biased. So if you make the connections in this way, we can able to operate the transistor in any of three regions. So in the cutoff region, it acts like a off switch. In the saturation region, it acts like a on switch. In the active region, it acts like an amplifier. So these are the applications of the transistor according to the operation or operating region. Next, what is voltage gain? So voltage gain is the ratio of output voltage to input voltage. We will indicate with AV, it is V0 by Vi, and it is unitless quantity. And what is Q point or operating point? So the point at which DC load line intersects the middle point of active region is called the operating point. Generally, in the case of transistor, if we take the output characteristics in the CE configuration, that is VCE versus IC characteristics, we will get the curves like this. Okay, on this particular curves, if I draw the load line, so wherever this load line intersecting in the midpoint of the characteristics, that indicates the Q point here. So to get this Q point, we have to draw the DC load line. To draw the DC load line, we have to find this voltage and this current. Next, what is an amplifier? So here amplifier is an electronic device that increases the voltage level or current level or power level of the signal here. So generally these amplifiers are used in wireless communications as well as in the broadcasting, and in the audio equipment also we can utilize this. So these amplifiers are in two types: weak signal amplifiers as well as power signal amplifiers. That is nothing but voltage amplifiers or power amplifiers. Voltage amplifiers can able to amplify the low voltage signals or low frequency signals. Power amplifiers will able to amplify high frequency signals. What is mean by biasing here? So biasing in electronics is a method of establishing a predetermined voltages as well as currents at various points of an electronic circuit for the purpose of establishing proper operating conditions in electronic components. What is mean by stabilization? Stabilization is nothing but once we fix the operating point, it should not vary with any variations in the component or any variations in the circuit. So that process we are calling it as the stabilization. So we can define it as the process of making the operating point independent of temperature changes or variations in transistor parameters is known as stabilization. So once the stabilization is achieved, the values of collector current as well as collector to emitter voltage become independent of variations in the temperature as well as if we change the transistor. And next, what are H parameters? So H parameters are also called as hybrid parameters. Hybrid means here mixed parameters. So here we are mixing two kinds of parameters. Those are H parameters and Y parameters. So if we combine these two parameters, we will get the mixed or hybrid parameters. Okay. So, and here also we are mixing the voltage as well as current ratios to represent the relationship between the voltage and current in the two-port network. So these H parameters are useful in describing the input-output characteristics of circuits wherever we cannot utilize Z parameters or Y parameters. So in some cases we cannot able to determine the voltage levels as well as current levels in the circuit by using the Z parameters as well as Y parameters. In that case, we are going to utilize the mixing of the two parameters, those are H parameters, to find the voltage and current levels in the circuit. Give the relationship between voltage and current in H parameter model. See here, in order to indicate the relationship between the voltage and currents in the H parameter model, first of all we have to take the input voltage and output current. So these two are the dependent parameters. So this I1, V2 are the independent parameters. So if you write the relation of the dependent parameters in terms of independent parameters, those indicates the H parameter model here. So this H11, H12, H21 and H22 are the four different H parameter models by mixing the voltage current levels as well as Z and Y parameters. So define H11 here. So H11 is nothing but the input impedance here. It is the ratio of input voltage to input current in the two-port network. And while calculating this, the output must be short-circuited here. So that we can write it as it is the ratio of input voltage to input current whenever the output voltage is 0. So it is known as short circuit input impedance. H11 is nothing but the short circuit input impedance. Why we are calling it as short circuit means output terminals are short circuited here, and the input impedance is indicated by these two parameters. And next define H21. So it is the ratio of output current to the input current at the output port is short circuit. That is nothing but I2 by I1 whenever V2 equal to 0. So it is called as again short circuit current again here. And next define H12. So it is the ratio of input voltage to output voltage. Okay. So in this case, here it is the open circuited input port. Okay, it is the ratio of input voltage to output voltage whenever the input port is open circuited. So this is the open circuit reverse voltage gain. And next define H21. So it is the ratio of output current to output voltage at the open circuited input port. So that we can write it as I2 by V2 whenever I1 is equal to 0. So it is called as open circuit output admittance. So here V1 is the input voltage, V2 is the output voltage, I1 is the input current, I2 is the output current, okay, and H11 is the input impedance, H12 is the reverse voltage gain, and H21 is the forward current gain, and H22 is the output admittance. So these four are the H parameters we can derive from the any two-port network. So in the case of transistor, we are going to derive this. So these parameters are, so this H11 is HIE in the case of common emitter, HIC in the common collector, HIB in the common base configuration. And similarly, this one H12 is HRE in the common emitter, HRC in the common collector, HRB in the common base configuration. And this one is HFE in the common emitter, HFC in the common collector, HFB in the common base configuration. And the last parameter, this one is HOE in the common emitter configuration, HOC in the common collector configuration, HOB in the common base configuration. So depends upon this subscript, we can able to differentiate whether it is belongs to the which type of configuration. So the first subscript is similar in all the configurations. So the second subscript is changing, depends upon the configuration here, whether it is common emitter or common base or common collector configuration. So in this session, we discussed all the definitions as well as terms which are present in the diode circuits module. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.